Think about the last time you sat down at a restaurant. There was likely no physical menu, just a small, pixelated square stuck to the corner of the table. You pulled out your phone, scanned it, and instantly, a world of data appeared on your screen. For years, this strange, boxy pattern was considered a failed technology, a clunky tool that most people ignored. Then, the global pandemic happened, and almost overnight it became the most important square in the world. It saved the hospitality industry, tracked our health, and bridged the gap between the physical and digital worlds. But here's the secret. The Quick Response Code, or QR code, was never meant for menus, concert tickets, or digital payments. It wasn't even designed for the general public. It was born in the loud, grease-stained factories of the Japanese automotive industry to solve a problem involving car parts. And believe it or not, the inspiration for its design didn't come from a computer lab, but from an ancient board game. Today, we're uncovering the story of how a lunch break hobby sparked a scanned revolution. To understand the QR code, we first have to look at its predecessor, the traditional barcode. You know it well. Those vertical black lines of varying widths that you see on every cereal box and soda bottle. Invented in the 1970s, the barcode was a miracle for supermarkets. But by the early 1990s, the industrial world was hitting a wall. You see, a standard barcode is one-dimensional. It only holds data horizontally. This limits its capacity to about 20 alphanumeric characters. That's barely enough for a serial number. In the 1990s, Denso Wave, a subsidiary of the Toyota Group, was struggling with this limitation. They were responsible for tracking thousands of car parts moving through massive assembly lines. Because a single barcode couldn't hold enough information, workers were forced to scan up to 10 different barcodes on a single box, just to know what was inside, where it was going, and which car it belonged to. Imagine being a worker on a high-speed assembly line. Your hand is constantly clicking a scanner, over and over, trying to catch every individual strip of lines. It was exhausting, prone to error, and incredibly slow. The beep 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 of the scanners was the sound of a system that was breaking down. The industry desperately needed a way to store more information in a smaller space. They needed a code that could be read faster, from any direction. The task of finding a solution fell to a young engineer named Masahiro Hara. Masahiro Hara wasn't looking for a digital breakthrough. He was looking for efficiency. He knew that to store more data, he couldn't just make the barcode longer. It would eventually become too big to fit on the parts. He had to go too deep. The breakthrough came during Hara's lunch break. He was a frequent player of Go, a traditional Japanese strategy game played with black and white stones on a square grid. As he looked down at the board, he realized that the arrangement of the stones on the grid represented a massive amount of information. If he could create a code that functioned like a Go board, storing data both horizontally and vertically, he could exponentially increase the capacity. He realized that a 2D grid could hold 200 times more data than a standard barcode. We're talking about thousands of characters instead of 20. It could store kanji, kana, and Latin symbols, making it perfect for the Japanese market. But there was a massive technical hurdle. If you put that much information into a tiny square, how does a scanner know where the code begins and ends? If the code is tilted or if it's moving at 60 miles per hour on a conveyor belt, the scanner usually gets confused. Hara and his team spent months trying to find a way to make the code readable from every angle. They needed a specific pattern that a computer could recognize instantly, something that didn't appear often in nature or in a messy factory environment. The solution turned out to be the 3 large squares you see in the corners of every QR code today. These are called position detection patterns. To find the perfect shape for these squares, Hara's team did something fascinating. They analyzed the ratio of black to white areas, printed materials, everything from newspapers to magazines to junk mail, to see what patterns occurred most frequently. They eventually found a ratio that was incredibly rare. 1:1.3, 1.1. By creating squares with this specific internal thickness, they ensured that a scanner could identify the code's orientation in a fraction of a second. Whether the code was upside down, sideways, or skewed, Those three squares acted as anchors. In 1994, Denso Wave officially released the QR code, which stood for Quick Response. It was a massive success in the automotive world. Parts were tracked with 100% accuracy at lightning speed. But the story didn't end there. Most companies would have patented the technology and charged a fortune for anyone else to use it. But Denso Wave made a legendary decision. While they held the patent, they declared they would not exercise it. They made the QR code open source and free for the world to use. They wanted the technology to grow beyond the factory floor. For years, the QR code was a tool in search of a purpose. It appeared in magazines and on billboards in the 2010s, but it never quite stuck until smartphones became universal. Today, that humble grid inspired by a board game is the bridge between our physical and digital lives. It's how we pay for groceries, how we join Wi-Fi networks, and how we access information instantly. The QR code is a reminder that the best solutions often come from looking at the world differently, taking an ancient game and turning it into a modern miracle. It's a story of how open-source thinking can change the world more than a closed-off patent ever could. Next time you scan a menu, remember Masahiro Hara and his Go board. You're not just looking at a link, you're looking at a scanned revolution.